All right, students. It is Tuesday afternoon, and today I assigned you the Quiz B, front and back, and I've got every problem here, and I'm going to go through each problem. My hope is that maybe you will get my text or something tonight, and you'll have the opportunity to see how to do these problems if you need help with anything. So here we go. Number one, solve -8 equals x over 2 for x. So I'm going to rewrite that so I have a little more room for work. Remember that I asked you to do your work on a separate piece of paper so that there's more room. You can staple that tomorrow when you get into class. X over 2 means x divided by 2, so I'm going to multiply both sides by 2 to get rid of it. Some of you like to cancel out. We'll do that. And I get x equals -16. Number one's a pretty easy question. Number two, Tanya is saving money to buy a computer that costs $375. She's already saved $75, and each week she adds $25 to her savings. How many weeks will it take to save enough money to buy her computer? So we're looking for how many weeks. I'll probably just call that W. Now I know she needs a total of $375, and that's made up of the $25 per week plus the amount she already has saved, which is 75. So $25 every week plus the 75 she has. How many weeks would it take to get to $375? So we're going to subtract 75 from both sides. We're left with 300 equals 25W. Divide both sides by 25. It looks like W equals, so let me see here, 12. So the answer is C. All right, number three. What is the best first step for solving the equation and list this equation? So remember, what I like looking for first is what number on the same side of the variable, so on this right side, is most by itself. And I would say this 5 down here is all by itself, and it's being divided. So the opposite of division is to multiply both sides by 5. The answer is C. Number 4. What is the solution for the equation? Negative 3.2 equals 2.5 plus 1.2. We're going to have to get rid of this 2.5. We're going to have to get rid of this 1.2. Which one seems most by itself? I would say the 2.5, so let's get rid of that. We're subtracting. Because the 2.5 is positive, we're going to subtract to get rid of it. And we'll subtract 2.5 on this side as well. And these cancel out. I'm left with 1.2m equals negative, oh, that looks like 5.7. Divide both sides by the coefficient of 1.2. And I'm going to use my calculator on that because I just don't know. I know it's going to be negative because a negative divided by positive is negative. We've got 5.2, can't type, 5.2 divided by 1.2. Well, it looks like I'm getting negative 4.3 repeating. I hope I did that right. All right, number 5, we're going to skip. I'm not worried about number 5. Number 6. We have a building that is 15 meters tall. It casts a shadow that is 6 meters long. Remember today in class, I said to do something. I said draw a picture. So that's what we'll do. We've got a building. It's a nice building. 15 meters tall, casting a shadow, 6 meters long. Now, at the same time, it's got a tree. So we've got another tree. I don't know how tall the tree is. We'll just make this nice tree. Well, that's pretty bad. The tree casts a shadow that is 9 meters long. It's longer than the building. How tall is the tree? I don't know, so we'll call that x. So the ratio I would set up, I always like to start with my variable, and I'm going to go x over 9 equals, let's see, x was the height. The height of the building is 15. The shadow was 9. The shadow is 6. Okay. Now if we multiply both sides by 9, to get rid of the divide by 9. Now we have x equals 30. Let me double check my math. Oh, I didn't do that right. Let me see here. 3, oh, yeah, I didn't do that right. Back it up a second. We're going to 15 divided by 6 times 9. Oh, I'm getting all sorts of answers here. Hold on. 15 divided by 6 is 2.5. Times that by 9. There we go. 22.5 meters. Okay. It's really important that sometimes you recognize if you make a mistake because the number comes out weird or something like that. You need to redo it. That's what I just did. Okay, number 7. A bottle can hold 2.7 liters of water. About how many gallons can the bottle hold? Round to the nearest hundredth. This is one of those ones where I start with what I have, which is 2.7 liters. And it's not in fractions, so let's make it into a fraction. And we want to end it in gallons. So there we go. Multiply by a conversion factor. Conversion factor. This changes it from liter to gallons. Liters on top, I wanted to cancel out, so I'm going to put liters on the bottom and replacing it with gallons. So we find out that 1 liter is equal to about 0.26 gallons. If it had been the other way around, I would have switched the numbers around, but that's not what it is. So I'm going to multiply these two. Just go 2.75 times 0.26. It looks like my answer is 6.565 gallons. Now I'm going to give you a little hint. If you put that answer, you're going to get it wrong because it says round to the nearest hundredth. The hundredth spot is the second decimal spot. So we need to go 6.5. Now I just got to decide, do I keep it at 6 or do I go up to 7? I look over, the 5 tells it go up to 7. So 6.57 gallons. All right, let's go to 8. Oh, 8's a big problem. Let's see if I can shrink this down a little bit or move it so I can see everything. We've got a train. Train is traveling 125.5 miles. So I'm going to write that down. 125.5 miles in 150 minutes. I'll put miles. Okay. 1 mile is about 1.61 kilometers. Which of the following is closest to the train speed in kilometers per hour? Okay, I've got a lot of things I got to change. I might have wrote too big. Let's see if I can fix this. Let's see. Okay, I got that. Let's give myself some more room here. I want to end not in miles per minute, but kilometers per hour. So I know I have to do some conversion factors. Matter of fact, I'm going to do 2 of them. Changing miles to kilometer, I could have put miles on the bottom, kilometer on top, because that's what I'm replacing. The miles will be able to cancel out. That's why I put 1 on top, 1 on the bottom. Now it tells me that 1 mile is about 1.61 kilometers. So 1.61 kilometers is equal to a mile. And that's good. Now I got kilometers on top, but I'm still got minutes on the bottom when I want hours on the bottom. So let's get rid of minutes. Cancel it out. I'm putting on top now because it was already on the bottom and replacing it with hours. What do I know about minutes and hours? Well, I know that there are 60 minutes in 1 hour. So the minutes cancel out. I'm left with kilometers per hour, which is what I'm looking for. And now I'm just going to do my multiplication. I got to go over to my trusty calculator here. I'm going to go 125.5 times 1.61 times 60 gives me a rather large number, and I'm going to divide that by the only number that's really on the bottom, which is 150, divided by 150. And looks like we go about 80 0.8 kilometers per hour. Hopefully I did that right. All right, number 9. Which of the following is the most precise? Oh, this is a nice, quick, easy one. The most precise is the one that goes out to the, well, first I look at labels. They're all in inches, so I don't have to worry about that. Then I look which one goes to the furthest decimal. This one goes to the thousandth spot. So this one is most precise. The answer should have been C. If it said least precise, the answer would have been A, because it only goes to the one spot. All right, let's look at 10. Which of these following numbers has 3 significant digits? Remember that we had 3 rules for significant digits. I can underline everything that isn't a 0. So I'm going to do that right off the bat. All of those aren't zeros. Now, the second thing, I look for any zeros that are in between other significant digits. I don't see any zeros that are in between. And the third thing I look for is zeros that are at the end of the number and also past a decimal. Well, this one's past a decimal, but it's not at the end. This one's past a decimal, and it is at the end. I'm going to underline that one. That one looks good. And this one's at the end, but not past a decimal. Same with this one. So I'd say this one is a yes, and this one has 2, so that's no good. And these also have 2. Okay? All right, number 11. 2.5 equals x over 6. Oh, nice and easy one. X divided by 6. I multiply both sides by 6. And I get x equals, let me make sure, I think I know what the answer is. I am right. X equals 15. Oh, number 12 gives us a nice big one. Negative 4, I'm going to rewrite this. Negative 4 equals 12p plus 10 all over 2. Remember when I have this big division bar over something, I'm going to get rid of that first, get rid of it by multiplying. To get rid of divide, we're going to multiply by 2. 2 times negative 4 is negative 8. These 2's cancel out. I'm left with 12p plus 10. Now look, what number is most by itself? I'd say the 10 is, so let's subtract 10. Subtract 10. I get 12p equals, well, negative 8 minus 10 is negative 18. If I divide by 12, I divide by 12. Looks like it's negative, I'd say that's negative 1.5. Let me make sure. Hey, I got that one right. I can check to see if that's right by putting negative 1.5 in here. So I'm going to do that really quick. I'm going to go 12 times 1.5. So that would have been negative 18. And let's see, negative 18 plus 10 would be negative 8. If I divide that by 2, I got negative 4, and my answer is correct. So I did a quick check just to see if my answer was right. I did that on my calculator. You can do it on paper too, whichever is easiest for you. All right, 13, we got Dante's cell phone company is charging him $45 a month for unlimited calls and internet and 25 cents a text message. His last phone bill was $60.50. How many text messages did he send last month? So we know our total is $60.50. Now that's made up of his $45 a month plus 25 cents for every text message. I'll just call that T. Well, let's get rid of the $45 he pays right off the bat. I'm left with 0.25T equals 15.50. If we divide that by 0.25 and divide that by 0.25, looks like he sent a bunch of texts. Let's see how much he sent. 15.5 divided by 0.25. He sent 62 texts. All right, maybe it's not that much. He sent 62 texts. All right, number 14. Thomas is building a fence around his garden. He made a scale drawing as shown below. 4 centimeters by 2 centimeters. This would be another 4. This would be 2. And it says, what is the perimeter of the actual fence? And we did something like this in class the other day. Well, if I was to do it in centimeters, I got 4, 8, 10, 12 centimeters. But each centimeter is worth 1.5 meters. So 12 times 1.5 is 18 meters. That's the answer I'm looking for. Okay? All right, let's go to 15. Mr. Swanson drove 150 miles in 4 hours at a constant speed. Plot the points on the graph. Well, if he drove 150 in 4 hours, let's label those 150 miles in 4 hours. If I divide that by 4, I get 37.5 miles per hour. Well, at 0, he hadn't gone anywhere. And we know from the problem in 4 hours he went 150. So 4 hours he went 150. And at 1 he went 30. Well, let's see, this is 15, 30, 45. So it's somewhere right in between here. And at 2 hours he went 75. It should be right about here. And at 3 hours, let's see, 37.5 times 3 is 112.5, which would be somewhere right about here. And that's all you have to do on that problem. And I think if we were to lower this a little bit, you would see that this says hours on it. All right, for 16 and 19, we're going to use this table. So we're going to have to come back to this a few times. Were more precise measurements taken when Tanya was 6 or 8? So we're going to look at years 6 and 8. More precise. Well, 6, it was 45. At 8, it was 51.5. So the more precise one uses the 10th spot. So the answer was 8 years old. Which has the highest significant digits and how many? Well, let's go back to the table. Most significant digits. Well, this one has 3, 1, 4. That's pretty good. 45 has 2. That has 2. That has 3. This one has the most with 4 of them. And which one has the least? That's the next problem. That one's going to be 40. It only has 1. Okay? So this one had 4. I don't remember the number. This one had 1. I think that was 40. Okay? All right, 19. Tanya's mother is. Oh, we talked about that is. Is means equal. Okay, so Tanya's mother is. I don't know how much Tanya's mother. So mother. I'm just going to write mother. Sometimes you don't have to use a variable. Sometimes you can use a word. Is 1.5 times, we're going to times something, as tall as Tanya. Okay, so this is for Tanya when she was 6. Oh, well, I now know what Tanya is. Tanya was 6. So how tall is Tanya's mother? You don't even have to really solve this. 1.5 times 6. 1.5 times 6 is 9. It says use the correct number of significant digits. Let's see. When I'm multiplying, I count the significant digits of the lowest one, which is 6. There's only one significant digit. I still only have one significant digit, so my answer is 9. If it had more significant digits, then I would have had to round. All right, so that's about it. It took me about 18, 19 minutes to go through all those problems, and I went really fast. That's why I gave you some time in class yesterday to work on it. Hopefully you got through it. Hopefully this helps you out with your homework, and we might take a look at this tomorrow in class. Hope everyone has a good night.